All right, so we are on chapter 8, section 5, and we're talking about dilution. And dilution, whenever you think of dilution, you're changing a solution from being very high concentration to very low concentration. And so the easy way to think about this, right, is if you ever had some of those flavoring things that you like squeeze, it's like the Mio drinks or whatever it is, right? It's this container that is full of very, very concentrated stuff. And you just put a quick squeeze. It doesn't take a lot, unless you're my son who likes to like really squeeze it and put so much in that it's disgusting. But normal people, you put a squeeze in, right? And you don't have to put a lot, and you stir it up, and then it's good and flavorful, right? So, but would you want to drink straight from the concentrated solution that you get? No, right? It's too concentrated, it's too much. So when you did that quick squeeze, you put a certain number of molecules into your glass of water. And so the same number of molecules that were in like this little stream, like maybe you put a teaspoon, right, of flavoring into a bottle of water. So the number of molecules that were in that teaspoon are the same number of molecules that are in this big glass of water now, but they're just dispersed out. So a lot of times you can tell with color, with those kind of things. Right, the concentrated solution is dark, and then the diluted solution is light. So you just have to remember that the amount of their solute, what was in that concentrated drink solution, the amount of that is the same as what's in your final diluted solution. So the volume increased. You went from having a teaspoon to having a big old glass of water, right? So the concentration, so what happened? The concentration decreased. You went from high concentration to low concentration. Your number of moles is the same, but you're diluting your sample, okay? So just think about it kind of that way. There's one equation, and this equation is on your equation sheet, but all it takes into account is our initial concentration, our final concentration, our initial volume, and our final volume. And so that's 4 different variables that we can put together in one formula. If you know 3 of the 4, you can solve for the 4th. So you need to be able to plug it in any way, shape, or form and be able to solve for the 4th. And we'll do some. It's super easy. So dilution equations work with any concentration unit, so long as the initial concentration and the final concentration have the same units. And same thing with volume, as long as the initial volume and the final volume had the same units. So a lot of times you're going to use this in the health field because a lot of pharmaceuticals are stored as a highly concentrated solution. And then when you're ready to give some to the patient, you make a solution, so you dilute, so you have a stock, it's called, that's the stock, and you make a working solution, or you make what you're going to give the patient. Right? And so you have to look at what you know about the stock, and usually what you know is the volume that you want to make your final solution. So then you need to know how much of my original stock do I need to put in to make my final solution. It is not like the Mio drink. You can't just like squeeze a little bit of drug and go, oh yeah, that's probably good. You really want to know for sure that how much drug you're giving your patient. Okay, so a lot of times, right, dilution factors can speed things up, right? It's really useful if we don't know the actual concentration, but we say, okay, this is a 20x stock, and I want my working solution to be 1x. What are you going to do? That's just a 20-fold dilution, right? So think about like if you're in the kitchen. And if you've ever had Campbell's condensed soup, have you ever done that? Like, I really like the tomato soup. And so what you do is you mix 1 can of soup concentrate, you pour it into your pot, and then you fill up the can with water, and then you pour that into your pot, right? So what did you do in order to do that? You had your total solution. Here's your total solution was this is your solution. You had water plus the soup, that's your total solution, over your original stock concentration, right? So your stock was 1 can, and then you put in a can of water plus the stock. So that's 2 over 1. And so that gives you a dilution factor of 2. Okay. And we'll do some examples, right? A lot of times this happens in a lab when you need a large volume of solution, but it's really hard to store a whole lot of a very dilute substance. So what we do is we store a little bit of the highly concentrated stuff, and then all we do is dilute it to make it the usable form. And so this happens all the time in pharmacies and that kind of stuff. All right, so let's go. Yep, let's go do some problems. Okay. So whenever we're doing kind of these problems, what you always want to remember is your formula. So go look, find your formula. Your formula should be concentration initial, volume initial equal to concentration final times volume final. Okay, you can always go back and find that formula. So now read your question. How many liters of a 0.5% mass by volume KCl for solution can be prepared from 2.0 liters of a 1% mass by volume stock solution? Oh, lots of information there, but it's not so bad. They're telling you that this is the stock. Oh, that's really weird, but that's okay. Okay, so they're telling you this is the stock. So the stock is initial. Those are your initial values. That's your initial volume and your initial concentration. And what they're telling you is that you have a final concentration of 0.15% mass by volume. And the question is, how many liters? So what we don't know is our volume final. Okay, so now all you have to do is plug things in. I know all my initial values. My initial values is 1.0% mass by volume. And then I'm going to multiply that times my 2 liters. And then I'm going to get my volume final, I don't know, so that's my unknown. And then my concentration is 0.15% mass by volume. So all I have to do is divide, right? That cancels, divide by 0.15% mass by volume. And what do I get? Let's see, what did I get? I did this one, 13 liters. You should get 13 liters, okay? So always go get your formula. It's not a big deal. Go get it off the equation sheet, okay? So put your formula, C initial, V initial, C final, V final. So concentration initial times volume initial equals concentration final times volume final. So what is the concentration of the resulting solution? Okay, so this is telling me that I don't know what my concentration of my resulting solution, so that's my final. If we have 450 milliliters of our 15% glucose, so this is my volume initial and my concentration initial, is diluted to a final volume of 2.0. So this is VF. So let's plug things in. Our initial was 15% mass by volume. And then our volume initial was 450 milliliters. And just remember that it doesn't matter what your units are, so long as it's the same unit on the left as it is on the right. Okay, now, be careful with this. We have a final volume of 2 liters. This is in milliliters. So you need to convert 2 liters. So how are we going to do that? We know in 1 liter, there's 1,000 milliliters. So that gives us 2,000 milliliters. Okay, so 2,000 milliliters. And we don't know what our concentration final is. So we're going to divide by 2,000 milliliters, divide by 2,000 milliliters, and always check to make sure that your units cancel. If your units don't cancel, that's how you know you need to go back and convert. Okay, so what do you get on this one? You should get a 3.4% mass by volume. All right, 8.43. How would you prepare a 250 milliliters of 0.225% mass by volume sodium chloride solution from a 0.9% mass by volume sodium chloride stock solution? This is a dilution. It's another dilution. So use your formula, right? And let's plug in. How would we prepare it? Okay, so now you have to know what's your final and what's your initial. So be careful with this one. This is my final. This is what I'm trying to prepare. This is my initial because it's my stock. So be careful about that. Okay. So here I'm given my concentration initial as 90% mass by volume. I don't know my initial. I have 250 milliliters, 0.225. Okay. So now I'm going to divide by 0.90. So what do I get? What you should get in this one is 63 milliliters. Now, be careful with this because this says, how would you prepare, not what volume, but how would you prepare it? Okay, I know the volume of my stock that I need, but I need to be able to say what I'm going to do. So we need to make a statement. So I'm going to add 63 milliliters of the stock, 0.90% mass by volume NaCl solution to, now you want to bring it up to the final volume, which is 250 milliliters. If I added 63 milliliters plus 250 milliliters, I would be over and my concentration would be wrong. So what I need to do is get like a graduated cylinder out, and I'm going to first pour 63 milliliters into it. Then I'm going to add enough water to bring it up to 250 milliliters. I don't want 313, right? I want 250. So add 63 mils of the stock to enough water for a total volume of 250 milliliters. So be very careful about that, okay? All right, 8.4, ooh, last one, 8.45. All right, you must dispense a Previdone iodine solution for an abrasion. You have a 12x stock solution. How much stock solution will you need to prepare 250 milliliters of a 1x solution? So you could do this two ways. I'm going to show you the way we've been doing it, and then I'll show you the final way, the other way. So do your same CI, VI, CF, VF. So what do I know? Well, I have a 12x stock. So this is my initial. Remember, stock is always initial. And this is my final. So my initial is 12x. And it doesn't matter what the x is, as long as it's x on the other side as well. So I don't know my volume initial. My concentration final is 1x, and my volume final is 250 milliliters. So I'm going to divide by 250. I don't have to, you could also do by 1x, but right, it's going to cancel. It's just 1. Oh, I'm doing that the wrong way. Ha ha ha. Hello. Okay, sorry, y'all. 1x and then 250 milliliters. I'm trying to get volume initial, so I need to divide by 12x. Divide by 12x. That was funny. So VI is 250 divided by 12. So you should get 21 milliliters, right, of my stock. This is how much I need to prepare my 250 milliliter solution. So I would put 21 milliliters in, and then I would fill it up to 250 milliliters. So that's one way that you can do it. The other way that you can do it is if you know your dilution factor, right? In this case, we know that our dilution factor is 12 because it's a 12x solution. So to get our initial volume that we need, we do our final volume divided by the dilution, dilution factor. And so what do we get? We get 250 divided by 12. But 21, not 12. It's the same thing. Doesn't matter to me how you do it. Okay, that's it. Have a great rest of y'all day.